And then most important contribution was given by Lothar Mayer in 1868, and then just after by Mendeleev who was a Russian, and Lothar Mayer was, I think, an English, or I don't know, don't recall. He is a German actually. Yes, it's already written. I just mentioned it. So it's a German and Russian contribution. Lothar Mayer just prepared or understand the classification, or about to propose the classification, or you can say Mendeleev and Lothar Mayer parallelly think on a same track, and on the basis of their both contribution of their both periodic table, or the just one step back or very close to modern periodic table is developed. And what they have, Mendeleev ultimately was found responsible for the publishing the periodic law for the first time, but we cannot neglect the contribution of Lothar Mayer, because he is also equally responsible, and he also contributed, but on a different area or in a different place. So the first time the periodic law was stated, and that is the properties of the elements are a periodic function of their atomic weight. Properties of elements are periodic function. Periodic function means the properties are going to be repeat after a certain periods or certain steps, right? And these certain steps, or this certainty in repetition of property would depend upon atomic weight. That's it. So this is the you can say first periodic table or periodic law given by Mendeleev. Mendeleev also predicted and left some place blank in his periodic table by assuming that in future some new element would be discovered, and he at his time also calculated or predicted the atomic weight of those elements and named those elements as aluminium. He predicted, and later on the aluminium with atomic weight as he predicted was 68 was discovered as gallium. He also predicted or left a place blank with atomic number 72 atomic weight 72 as silicon predicted, and later this place was filled by discovery of germanium with atomic weight of 72. So he predicted quite close to those discovered later. So this is how the accuracy of the prediction of Mendeleev according to the properties and their repetition or their periodicity. Now comes the modern periodic law. Let's take our time, see how the periodic law was changed from this. Because in Mendeleev's periodic table, they have just concerned about atomic weight. Each and every one before the modern periodic table, they all are concerned with atomic weight. Nobody think about atomic numbers. But as the time changes and discoveries are made, like different spectroscopic techniques, different instrumental methods of analysis are developed, the scientists try to think something else to accurately classify the elements, right? So in this way they have tried and successfully considered a different thing to classify elements, and that is I'm just going to tell you, and that is basically what atomic number. So after Mendeleev's periodic table in 1913, scientists used the atomic number in place of atomic weight to classify the elements and to understand the periodicity of different elements in physical and chemical properties on the basis of atomic number. So why they think about atomic number, and why and how they think that atomic number should be replaced with atomic weight of previous classifications of elements should be replaced with atomic number. So that is given here in a very short, in very brief. That is, in 13, the English physicist mainly Henry Moseley, he is responsible for this modern periodic law. He is observed irregularities in the characteristics of X-rays. So this is very important. X-rays, the spectra of elements, and he plots frequency of X-ray emitted against atomic numbers of element. What he observed? He observed that when he plot a frequency of X-ray emitted against atomic number of those element who is emitting X-ray, give a straight line and not the plot of frequency versus atomic mass or atomic weight. So Moseley observed, or when he tried to plot a graph between X-rays emitted by an element with the atomic number and the same X-ray emitted by the same element with its atomic mass of different elements, what he observed, that in case of X-rays emitted or the frequency of X-ray emitted and atomic number is plotted, he found a straight line. But in case of atomic mass, that was not true. And this is the actual plot of Moseley's study, in which you can see in this axis there are different types of elements are placed, and on x-axis the under root of frequency of X-rays emitted. So you can see there is a straight line between, or when the atomic number versus frequency is plotted. So this is why, or this is the reason why scientists start thinking or start classifying or arranging element on the basis of periodicity in atomic number and physical and chemical properties. Basically, question may be or should arise in your mind that what is X-ray and how they produce, and why this K alpha is written there. So I have just mentioned here for the sake of your understanding, so that you can also note it down. Just first let me read this, what is written here. Slakman notation: when an electron falls from the L shell to the K shell, the X-ray emitted is called K alpha X-ray. Basically, you know, this is a nucleus, and here is the different shell, K, L, M, and etc. And what is X-ray? When a high energy particle particles are bombarded on any element. For example, suppose the electron which is placed in K shell receives that energy and exit from the attraction force of nucleus and leave this place blank. Right, after receiving this enormous amount of energy which is in the form of bombarded particle, the electron of K shell is emitted out from the attraction force of nucleus and leave the K shell blank. and what happened, the electron which is placed in L shell will release some energy h nu and fall to this K shell, right? So when electron from L shell fall down by releasing some energy and reach to K, and the energy in the form of X-ray is emitted. So this is how X-rays is emitted, and the X-rays would be called as K alpha. X-rays would be called as K alpha because the element, the electron is falling on K shell. That's why it is called as K alpha. That's it. And that is also true in case of X-ray, XRD, X-ray diffraction method. X-ray diffraction in which copper K alpha radiation is used to analyze the crystallinity and amorphous nature of any material, right? So this is the modern periodic law and can be stated as the physical and chemical properties of the elements are periodic functions of their atomic numbers. This is very important. The physical and chemical properties of the elements are a periodic function of their atomic number. Why the physical and chemical properties of elements are periodic function of atomic number? See, atomic number is what? Number of protons which, except radioactive reaction, does not take part or does not leave the atom, right? And it is responsible for the for providing, in modern periodic table, to provide the place, and this is equal to number of electrons, right? And who is taking part in chemical reactions, and on the basis of which particle of atom the physical and chemical properties are governed, that is electron. So ultimately atomic number is representing electron, which is responsible for different types of chemical and physical properties of element. That's why in modern periodic table the physical and chemical properties of elements are periodic function of their atomic number. So that's it for today. I think in next lecture I will start again from the periodic tables and different types of elements and their position in periodic table, like details of periodic table. Thank you.